Everyone, I'm Rahul. So, till now in the Cadence simulation videos, we have learned how to make the schematic and how to simulate these things into ADEL window, how to do all those setups, and how to perform DC analysis. We have also learned how to annotate the various parameters, maybe nodes or maybe DC operating points, and we have seen how to print the DC operating point as well. And in this video, I'm going to explore the transient analysis. So before starting that, I would like to tell you, if you didn't watch the earlier videos, just go check it out. It will be useful. But if you came here only for transient analysis, just go ahead. So what is transient? In transient analysis, we generally plot with respect to time. This x axis is always time. So suppose we are talking about this inverter. So if we are giving input to this inverter, suppose this is the input and this y axis is the voltage. We are giving a pulse to this, or maybe repetitive clock. So the output would also be, so output will be something like this. Okay, so that's what we are going to perform next here. So in previous video we have done the simulation using ADEL window, but here I'll explain you ADEXL window, how to set up the simulation in that. So just click on this, create new view. Okay, all right, so you just click on test, click to add test. So from here you can add your schematic. So the name is first in ZZ, click OK. So that's how we add here. After that, expand this and see, you go to analysis. So again the similar window has popped up. Okay, so now we want to perform the transient analysis. So stop time 0.1 nano. Okay, keep it moderate and okay. Okay, so the convenient of this ADXL window is you can switch easily between the schematic and your analysis. So this is convenient. So as I said, we are going to do the transient analysis. So we are going to provide it a pulse at the input, but now it is a DC voltage. So I change this DC voltage to pulse. So I instantiate the pulse, V pulse. I'll delete this. The DC voltage maximum amplitude is 1.8 volt, and I need to provide these things, period, delay time and all. So suppose delay time is 1 nanosecond, rise time is also 1 nanosecond, fall time is also 1 nanosecond, and pulse width total say 50 nano, and the period is say 102 nanosecond. Okay, so the pulse is set. Press OK, check and save. For check and save, shift X. It's done. Now come to here, I'll set the analysis. So for this now I'll give 400 nano, the rest is okay. We don't have any design variable, otherwise we could have copied it from this option. Now what I'll do, I'll just run the simulation and see the things ahead. Click here. So it's running, what is showing. So the run is complete and this is without error, I think. Yeah, zero warning, zero notice. So similarly, so here it got saved. You can see, click on this, that window will pop up where you modified all those things. Okay, now I need to see the plot. Okay, so for plot I'll click here, right click, and then direct plot main from, similar to the previous one. So transient analysis, I add it to output also. Select the net on schematic. So we want to see the output. Something went wrong. So here I can remove this thing and I need to provide voltage V1 and V2. So I think voltage V1 is the initial voltage, that is 0, and V2 is the maximum voltage, that is 1.8 volt. I think this will be the only error. Let's see, I have modified it. Check and save, Shift X, and then I'll run it. Okay, zero warning. For plot, this plot already got added. You can see here. I just click here. So that's how it is showing me the output. But I don't know whether it is correct or not. So for that I need the input as well. Okay, so for this I'll add the input. So direct plot main from, I want to see the input voltage as well. So add to output and I select it here. So run finished. After that, these are the input and output. So input first, then I'll use here append, otherwise it will replace it. So I want to append out with the in. So here it is. So this yellow one is the output, and the red one is the input, and they are coming opposite, the inverted waveform. Okay, if I want to split this in two windows, okay, so now I can see clearly input, output. That's how we perform the transient operation. Okay, and here and today you also learned how to use the ADE Excel. So it's a bit convenient. We can see schematic in the simulation setup side by side, and we can add the things into it and run it. Although both are same, but I feel this is convenient. So that's it for now. I have kept few useful link in the description. You can check it out.